Right now, as you watch this video, something incredible is happening in the depths of space. Our entire galaxy, every star you've ever seen, every planet we've discovered, our sun, our Earth, is hurtling through the cosmos at 250,000 miles per hour toward an inevitable cosmic collision. In about 4.5 billion years, our Milky Way galaxy will collide head-on with our nearest major neighbor, Andromeda, in one of the most spectacular events the universe has to offer. This isn't science fiction. This is our cosmic destiny, written in the stars and confirmed by decades of astronomical observations. Welcome back to the channel. Today we're diving into one of the most mind-blowing stories in astronomy, the day two galaxies become one. We're going to explore what this collision will actually look like, whether humanity could survive to witness it, and surprisingly, why this galactic smash-up might not be the disaster you'd expect. To understand this cosmic collision, we need to examine the two massive galaxies involved in this future merger. First, let's look at our home galaxy, the Milky Way, a spiral galaxy containing somewhere between 100 to 400 billion stars. That's roughly 50 stars for every person who has ever lived on Earth. Our galaxy stretches about 100,000 light-years across, with prominent spiral arms that sweep out from a central bulge, harboring a supermassive black hole called Sagittarius, a star. This black hole weighs in at 4 million times the mass of our Sun. We're located in the Orion Arm, about 26,000 light-years from the galactic center, orbiting around that central black hole at roughly 515,000 miles per hour. The Milky Way is approaching a collision with Andromeda, also known as M31. Andromeda is the largest galaxy in our local group, containing over 1 trillion stars, making it more than twice as massive as our home galaxy. This galaxy spans an incredible 220,000 light-years in diameter, significantly larger than the Milky Way. Like our galaxy, Andromeda also hosts a central supermassive black hole, but this one is far more massive at roughly 100 million solar masses. Currently located 2.5 million light-years away, Andromeda appears as just a faint smudge to the naked eye on dark nights. However, it's racing toward us at 250,000 miles per hour, closing the gap by about 300,000 miles every single day. Both galaxies are members of what astronomers call the local group, a gravitationally bound collection of more than 80 galaxies. The third major galaxy is Triangulum, along with dozens of smaller satellite galaxies orbiting both the Milky Way and Andromeda. These gravitational interactions are already at work, slowly pulling our galaxies together despite the expansion of the universe itself. This collision is inevitable due to gravity. While the universe expands and most distant galaxies move away from us, objects in our local group are close enough that their mutual gravitational attraction overpowers cosmic expansion. The gravitational pull between these massive galaxies has been drawing them together for billions of years. We discovered this approaching collision through decades of careful observation. Edwin Hubble first identified Andromeda as a separate galaxy in the 1920s, revolutionizing our understanding of the universe's scale. But it wasn't until the Hubble Space Telescope began making precise measurements of Andromeda's motion that we confirmed our collision course. These proper motion studies, tracking tiny changes in Andromeda's position over years of observation, revealed the scientific reality. We're on a direct collision course with no possibility of missing each other. Let's walk through this cosmic collision step by step, from today all the way to the birth of a completely new galaxy. Right now, we can already observe evidence of our future collision. Andromeda appears as a faint oval patch in our night sky, roughly 6 times the width of the full moon when photographed with long exposures. Most people can't see it with the naked eye due to light pollution, but from a dark location, it's visible as a dim smudge. Over the next several billion years, this smudge will gradually grow larger and brighter as Andromeda approaches. Gravitational effects are already beginning. Subtle tidal forces are starting to influence the outer edges of both galaxies, though these changes are too small for us to detect with current technology. By this point, Andromeda will become prominently visible to anyone looking up at the night sky. It will appear as a distinct spiral galaxy, roughly the size of the full moon, but much dimmer and more spread out. The approaching galaxy's gravitational influence will begin affecting both galaxies more dramatically. Tidal forces will start distorting the outer spiral arms of both the Milky Way and Andromeda, stretching and warping their elegant structures. These gravitational interactions will compress gas clouds throughout both galaxies, triggering increased rates of star formation. The night sky will begin to show more bright, young blue stars as this cosmic construction project accelerates. Andromeda will now dominate the night sky, appearing several times larger than our current moon and displaying intricate spiral structure visible to the naked eye. The gravitational chaos will be in full swing. Stellar orbits throughout both galaxies will begin changing dramatically as the massive gravitational fields interact. Some stars will be accelerated to such high velocities that they'll be ejected entirely from both galaxies, flung into the emptiness of intergalactic space. Cosmic ray activity will increase significantly as the collision compresses magnetic fields and accelerates particles to higher energies. This marks the first pass-through of the galactic centers. The cores of both galaxies will swing past each other in a gravitational dance that defies easy description. Massive tidal streams of stars will be torn from both galaxies, creating spectacular bridges and tails of stellar material stretching across hundreds of thousands of light years. Star formation will reach extraordinary rates as gas clouds collide and compress throughout both galaxies. The two supermassive black holes at the centers will begin their own complex orbital dance, not yet merging, but gravitationally bound to each other. Rather than a single collision, this will be an extended process of multiple gravitational encounters. The galaxy cores will swing past each other several times, each passage further disrupting stellar orbits and mixing the stellar populations of both galaxies. Gradually, the elegant spiral arms will be destroyed, and the combined system will begin settling into the more rounded, elliptical structure typical of merged galaxies. During this chaotic period, the two central supermassive black holes will spiral closer together, eventually merging in a cataclysmic event that will send gravitational waves rippling across the universe. The final merged galaxy, which astronomers have nicknamed Milky Way, will have achieved gravitational equilibrium. This new elliptical galaxy will be significantly larger than either original galaxy, containing all the stars from both the Milky Way and Andromeda. The chaotic star formation of the merger period will have settled down, leaving behind a stable configuration with a single, more massive, supermassive black hole at its center. Milky will continue evolving over cosmic timescales, but the dramatic transformation will be complete. This new galaxy will be our cosmic home for the remainder of the universe's history. As Andromeda approaches over billions of years, the transformation of our night sky will be nothing short of extraordinary. Today, Andromeda appears as a faint smudge, roughly 6 times the width of the full moon, but visible only through telescopes or long-exposure photography. As the collision timeline progresses, this will change dramatically. 1 billion years before collision, Andromeda will become clearly visible to the naked eye as a distinct oval patch about the size of the full moon, but much fainter and more diffuse. Its spiral arms will become apparent, creating an ethereal, ghostly appearance against the star field. As it continues approaching, Andromeda will gradually brighten and expand, eventually spanning several degrees across the sky. Imagine the full moon growing to the size of your outstretched hand. The galaxy's color will shift from its current blue-white appearance to show more varied hues as different stellar populations become visible. Young, hot blue stars in the spiral arms will contrast with older, redder stars in the galactic center. During the final approach, Andromeda will dominate the night sky, appearing as a magnificent spiral structure larger than any constellation we know today. The familiar constellation patterns we've known throughout human history will gradually shift and change as stars from both galaxies mix together. Orion, the Big Dipper, Cassiopeia, all will slowly dissolve as stellar positions change over millions of years. The actual collision period will create the most spectacular light show in cosmic history. Massive regions of star formation will ignite throughout both galaxies as gas clouds collide and compress. These stellar nurseries will appear as brilliant pink and red nebulae scattered across the sky, visible even during daytime hours. Long streams of stars will be torn from both galaxies, creating sweeping arcs of light stretching across the entire sky. These tidal streams will constantly evolve, forming new patterns and structures as gravitational forces reshape the merging galaxies. New star clusters will form rapidly during this period, appearing as brilliant jewel-like collections of young, hot stars. The changing galactic structure will be visible over relatively short astronomical timescales, millions rather than billions of years. The orderly spiral arms will gradually dissolve into chaotic streams and eventually settle into the smooth, elliptical shape of the final merged galaxy. If we could create a time-lapse spanning the entire collision, it would reveal a cosmic dance of unparalleled beauty. The collision would appear as 2 spiral galaxies approaching, embracing and transforming into something entirely new. Different wavelengths of light would reveal different aspects of the merger. Infrared showing dust and star formation regions, X-rays revealing the activity around the central black holes, and visible light displaying the stellar populations. We can observe similar processes today in other galaxy collisions, like the antennae galaxies, which show us snapshots of what our own collision will look like at various stages. The transformation of our night sky will be complete. Familiar constellations will be replaced by entirely new stellar arrangements as stars from both galaxies intermingle. The Milky Way's band of light across our sky will disappear, replaced by the more uniform glow of an elliptical galaxy. Enhanced magnetic field interactions during the collision may create spectacular aurora displays, potentially visible at lower latitudes than ever before. The cosmic background radiation may show subtle changes as the merger affects the local cosmic environment, though these changes would only be detectable with sensitive instruments. Despite the dramatic name, our solar system will almost certainly survive completely intact. When astronomers talk about galaxy collisions, they're describing something fundamentally different from the crashes we experience in everyday life. The key insight is that galaxies are mostly empty space. Despite containing hundreds of billions of stars, the vast distances between those stars mean that actual star-to-star collisions are extraordinarily rare. A useful analogy is to think of galaxy collisions like two swarms of bees flying through each other. While the swarms intermingle and mix, individual bees rarely collide because there's so much empty space between them. To put this in perspective, our nearest stellar neighbor, Proxima Centauri, is about 25 trillion miles away. If our Sun were the size of a marble, Proxima Centauri would be another marble located about 350 miles away. Even when two galaxies merge, these enormous distances mean that stars typically pass by each other without any direct interaction. Astronomers have calculated the specific probability of our Sun colliding with another star during the Milky Way Andromeda merger, and the odds are incredibly low, less than 1 in several billion. You're more likely to win the lottery multiple times in a row than to see our Sun collide with another star during this galactic merger. Based on detailed computer simulations, there are 4 possible outcomes for our solar system, each with different probabilities. The most likely scenario, with roughly a 75% probability, is that our solar system passes through the collision completely unaffected. The planets will maintain their current orbits around the Sun, and life on Earth, if it still exists, would continue as normal. The only change would be our location within the new merged galaxy and the appearance of different stars in our neighborhood. We might find ourselves in the outskirts of Milky rather than in a spiral arm, but our local solar system would remain unchanged. There's about a 20% chance of gravitational perturbation, where the gravitational influence of passing stars causes slight changes to our solar system structure. This might result in subtle alterations to planetary orbits over millions of years, or the disruption of distant objects in the Kuiper belt. These changes would be gradual and likely wouldn't threaten life on Earth. A more dramatic outcome, with roughly a 4% probability, is ejection from the galaxy entirely. Gravitational interactions during the merger could accelerate our entire solar system to such high velocities that we're flung into intergalactic space. While this sounds catastrophic, life could potentially survive this scenario. The Sun would continue burning normally, and planets with internal heat sources, like Earth with its radioactive core, or moons like Europa with tidal heating, could remain habitable even in the cosmic void. The least likely outcome, with about a 1% chance, is a close stellar encounter where another star actually passes through our solar system. This could disrupt planetary orbits, potentially ejecting outer planets or sending comets from the Oort cloud streaming toward the inner solar system. Such an event could pose significant challenges for any life that still exists on Earth. There's also the black hole factor to consider. When the supermassive black holes at the centers of both galaxies eventually merge, they'll produce tremendous gravitational waves and potentially eject some nearby stars at high velocities. However, since we're located far from the galactic center, this dramatic event is unlikely to directly affect our solar system. The merger will create an even more massive black hole at the center of Milky, but from our distance, this won't significantly change our galaxy's overall gravitational environment. To understand whether humanity could witness this galactic collision, we need to grasp the immense timescales involved. The collision will occur in 4.5 billion years. That's exactly the same amount of time that has passed since Earth first formed. We're talking about doubling our planet's entire history. To put this in evolutionary perspective, 4.5 billion years ago, Earth was a molten ball of rock with no atmosphere, no oceans, and certainly no life. The first simple bacteria wouldn't appear for another billion years. Complex cells took 3 billion years to evolve, and humans have only existed for about 300,000 years, a mere blink of an eye in cosmic terms. But here's the critical factor. Earth faces much more immediate challenges than the galactic collision. Our sun is gradually growing brighter as it ages, and in about 1 billion years, long before Andromeda arrives, the sun will enter its red giant phase. This stellar evolution will make Earth uninhabitable as our star expands and dramatically increases its energy output. Even before that, rising solar luminosity will trigger a runaway greenhouse effect in roughly 500 million to 1 billion years, causing Earth's oceans to evaporate completely. The habitable zone around our sun will shift outward, potentially making Mars more comfortable while turning Earth into a Venus-like inferno. So, will humanity witness the galactic collision? In our current biological form, almost certainly not. In 4.5 billion years, humanity could evolve into something completely unrecognizable. Develop technology that allows us to transcend biological limitations entirely, or spread across the galaxy through space colonization. We might become a post-human civilization, existing as digital consciousness, genetically engineered beings adapted to different environments, or merged with artificial intelligence in ways we can't currently fathom. The collision will likely be witnessed by some form of intelligence, whether evolved from humans, other Earth species, or entirely alien civilizations. Any advanced civilization capable of surviving such timescales would possess technology and capabilities that would seem magical to us today. That was the end of the video. If you feel interested, please do not forget to like and subscribe for more content like this.